Newton's first law. An object at rest remains at rest, and an object in motion remains in motion at constant speed in a straight line unless acted upon by an unbalanced force. Law of inertia. Tendency to risk change in motion.
This is Newton's first law.
An object at motion stays in motion unless acted upon by an outside force. Object at rest stays at rest unless acted upon by an outside force.
Object at rest stays at rest unless acted upon by an outside force, as you can see.
An object at motion stays in motion unless acted upon by an outside force. Go!
Newton's first law. An object in motion stays in motion unless acted upon by an unbalanced or opposite force.
Newton's second law. The acceleration of an object depends on its mass and the amount of force applied. Force equals mass times acceleration.
In the video clip you just watched, the volleyball player exerted an amount of force onto the volleyball, which made the acceleration more. If the volleyball player had hit the ball with less force, then the acceleration would have been less.
Second law. The more force I put on the ball, the more acceleration there will be. Example. Not that much. Now a lot more. Oh, but it's not faster.
Newton's second law. The acceleration of an object depends on its mass and the amount of force applied. You see here the trash can lid.
Newton's third law. Whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first.
You have a basketball and a basketball net. By shooting the basketball, you're exerting an equal force on the amount of force that the basketball is exerting on you. Newton's third law! Newton's third law!
Woo! Did you start it?
Yeah.
Okay. Newton's third law. When I push off of this boat, it will make me go backwards because I exerted the force on the boat, which then exerted onto me. Newton's third law. The flag is being blown straight forward and the pole is holding it back. So the wind is exerting force on the flag, making it go this way, but it is also exerting an equal and a same force on the pole, which is holding it there. Woo!
We are here with Rick Sanchez, commercial diver for Salty Dog Dive Service. Newton's first law.
Sometimes we use a boat when we are working, and when the boat is sitting at the dock and we are not using it, it will just sit there. Obviously, once we get on the boat and start the motor and give it gas, the boat will start to move. The more gas we give it, the faster it will move. If we need to slow down or stop, we can decrease the throttle, and we can sometimes use reverse to slow the boat down.
Okay, thank you. How would you say this second law affected your line of work?
Well, sometimes we use a tool underwater that we can clean the boat bottoms with. And if we need to, we can increase the throttle to spin the scrub brush faster. If the boat is dirtier and we need to scrub it harder, we can increase the speed by increasing the power to it.
Okay, thank you. And how about the third law?
Sometimes while we're working, we need to swim through the water. So in order for us to move forward, we need to kick with our feet and our fins, and we will kick, the water will move backwards, and we will move ourselves forward.
Okay. And that is the end of our segment for today.
Why I'm here? Nobody really knows.
Tell you you're singing.
bloopers. Bloopers. So I guess I'm a man now.
Stick to the status quo. Oh, if you want to be cool, follow one simple rule. Don't mess with the flow. No, no. Stick to the status quo. No, no, no. Stick to the status quo. If you want to be cool, follow one simple rule. Don't mess with the flow. No, no. Stick to the status quo. Listen, well, I'm ready to tell about a need that I cannot deny. Dude, there's no explanation for this awesome sensation. Yeah, I'm ready to let it fly. Speak your mind and you'll be heard. Well, if Troy can tell his secret, then I can tell mine. I play the cello. What's that? It's like a giant violin. Cool. Not another peep. No, no, no. No, no, no. Stick to the steps. We want to be cool. Follow one simple rule. Don't mess with the flow. No.
This was Newton's Laws. Thank you for watching. Done. We're done.